In this video, we are on page 12 in our student journals, and we're working through the extra practice in lesson 1.2. The following problems will have us work with vertical and horizontal stretches and shrinks, as well as combinations of transformations. So we're going to work through number 6 first. What they want us to do in number 6 is to write a function g that is the transformation given of f. Okay, so our function f of x is equal to negative 5x, and we need to take this function and do a vertical shrink by a factor of 1/5. So if you go back to our transformation rules, we're working with vertical stretches and shrinks. So they tell us that this is a vertical shrink. So when we're working with a shrink, remember our a value is going to be a number in between 0 and 1. Okay? And so it's by a factor of 1/5. So let's go ahead and write our a value. A is going to be 1/5. So our rule for vertical shrinks is that our function, our new function g of x, this shrink happens outside. We multiply outside the function. Remember, a is going to be multiplied by f of x outside the function. So g of x will be equal to my a value, which is 1/5, because we're doing a vertical shrink, times f of x. So now I need to take my f of x function, which is negative 5x, and substitute it in. So g of x will be equal to 1/5 times f of x, which is negative 5x. We just want to make sure we simplify this. And so I need to do, oops, sorry, I shouldn't have a negative there. I'm not sure why I put that. We need to do 1/5 times negative 5. So g of x is equal to 1/5 times negative 5 is negative 1, or negative 1x. We're going to skip number 7 and move on to number 8. Number 8, our function f of x is equal to 3x minus 9, and we need to write a new function that takes this function and does a horizontal stretch by a factor of 6. Remember, anything with horizontal is kind of opposite what we would think. So for a stretch, horizontal stretch, we're multiplying that a inside the function, and with stretch, we're going to take that factor and write it as a fraction between 0 and 1. So our a value here, even though it says by a factor of 6, because it's kind of opposite what we would think, our a value is going to be 1/6. So for horizontal stretches, my new function g of x will be equal to f of x, not f of x, I'm sorry, f of my a value 1/6 times x. Remember, I'm multiplying that inside the function. So now I'm ready to write my new function. Remember, since this is inside f of x, I'm taking 1/6 times x, or 1/6x, and I'm replacing x with that. So g of x is equal to 3 times 1/6 x. So instead of x, it's 1/6 x minus 9. I'm going to go ahead and simplify this. So this is equal to, let's see, 3 times 1/6 is 3/6 x minus 9. And I can reduce this fraction. 3/6 is the same as 1/2. So my final function, g of x, is equal to 1/2 x minus 9. Number 9. F of x is equal to the opposite of the absolute value of 8x minus 4. And we want to take this and do a horizontal shrink by a factor of 1/4. Remember, anything horizontal, think opposite of what you would naturally think. So with our horizontal shrink, we're going to take our factor, and it needs to be greater than 1. And remember, we're going to multiply by that inside the function. So my horizontal shrink is has a factor of 1/4, but my a value, remember, is 4. So g of x, my new function, will be equal to f of x, or f of a, which is 4 times x. Remember, that goes inside the parentheses right next to the x. And so like number 8 above, this is going to get replaced or placed in for x when I go to write my function. So g of x is equal to the opposite of the absolute value of 8 times not x, but times 4x minus 4. The only thing I need to do is just do this multiplication to simplify this. So g of x is equal to the opposite of 8 times 4x is 32x minus 4. Okay. Last one, number 10. Consider the function f of x equals the absolute value of x. So we're working with the parent absolute value function. Write a function g whose graph represents a reflection in the x-axis, followed by a horizontal stretch by a factor of 3, and a translation 5 units down of the graph of f. So multiple transformations are happening. We're going to be doing 3 different transformations, and we want to make sure we do these in order. So I'm going to kind of separate this into steps. Okay, we're going to take f of x, and we'll start with that f of x. And we're going to do 3 transformations to this. First, I'll kind of break it down. We're going to be doing the reflection. Then we'll take that new function and do a horizontal stretch. Then we'll take that new function and do the translation to get our final function that they want. Okay. So let's go ahead, let's do the reflection first, and it's a reflection in the x-axis. So I'm going to go ahead and just name this new function. I'll call it t of x. Okay. Remember, when we do reflections in the x-axis, we multiply by that negative outside the function. We take the opposite outside the function. So my new function t of x is going to be equal to the opposite of f of x. Okay. And so now if I replace the absolute value of x in for f of x, this function t of x is equal to the opposite of the absolute value of x. So that's my function that I get after I do the reflection. Now I need to take this new function t of x and do a horizontal stretch. So remember, when we do a horizontal stretch, it's kind of opposite what you would think. My factor is 3, but my a value, remember, because it's a horizontal stretch, it's in between 0 and 1. It's a fraction. So a is going to be 1/3. And this a value gets multiplied inside the function. So I'll call this new function, I'll call it h of x. Okay, so h of x, I need to do the horizontal stretch to t of x. So I'm going to multiply by that 1/3 inside the function. And so now I'm going to go ahead and substitute 1/3 x in for x in my function above. So h of x will be equal to negative the absolute value of not x, but instead 1/3 x. And that's what I have after the horizontal stretch. So lastly, to get our final function, They want us to take h of x and do a translation. And they tell us in the problem to do a translation 5 units down. So remember, with translations, we add or subtract outside the function. Okay, so we are going to be subtracting 5 outside the function. Okay, so for my final function, I'll just call it g of x. So g of x is going to be a translation of h of x 5 units down. So I'll take h of x and subtract 5 to get that translation. So g of x is equal to h of x, remember, is negative the absolute value of 1/3 x, and then I'd subtract 5. This is my final answer. It's the final function after I took the original and did all 3 transformations to it.